high above the thin blue layer of Earth's atmosphere, where silence becomes absolute and time feels slower. A small machine continues its endless journey around the planet. The Hubble Space Telescope floats in orbit like a forgotten eye that refuses to close. It does not blink. It does not sleep. It only watches. For decades, Hubble has been pointing its lens into the deep unknown, collecting light that has traveled across unimaginable distances. Light that began its journey before humans had even written history. Light that carries the echoes of stars that no longer exist. Every image it sends back to Earth is not just a picture. It is a time capsule, a message from the past written in photons. Down on Earth, in quiet control rooms filled with monitors and soft electronic hums, scientists interpret these messages. They see galaxies stretching across cosmic fields like islands in a dark ocean, spiral arms glowing with newborn stars, nebulas blooming like violent flowers of gas and dust. But Hubble is only the beginning, because even as Hubble continues its watch, humanity built something deeper, something colder, something more patient, something that does not look at space the way we do. It listens to the beginning of time. They called it the James Webb Space Telescope. Unlike Hubble, Webb does not orbit close to Earth. It drifts far beyond the moon, in a gravitational balance point, where Earth and Sun's forces cancel each other. A place of stability, a place of isolation, a place where light from the sun cannot disturb its vision. Webb was designed not to look at what is bright and near, but what is faint and ancient. It sees in infrared, meaning it can detect heat signatures from the earliest structures in the universe. It can look through cosmic dust that hides newborn stars. It can see galaxies forming when the universe was still young and chaotic. Together, Hubble and Webb form something rare in human history. Two eyes. One remembers the universe as it was. The other tries to see how it began. And somewhere between them lies the truth of everything. But the universe is not a quiet place. Even if it appears silent, it is constantly moving, expanding, collapsing, and reforming. Stars are born in violent clouds of gas. Black holes swallow entire systems without sound or warning. Galaxies drift apart like fragments of a broken mirror, stretched across infinity. Hubble once captured a single image that changed how humanity understood existence. A small patch of seemingly empty sky. When zoomed in, it revealed thousands of galaxies, each galaxy containing billions of stars, each star possibly hosting planets, each planet holding unknown possibilities. It was a reminder that emptiness is never truly empty, and Webb pushed this idea even further. When it turned its sensor toward the earliest regions of space, it saw something unexpected. Not darkness, not void, but structure, formation. The first hints of order emerging from chaos. The universe, still young, still unstable, but already building itself into complexity. Scientists stared at the data in disbelief, because what they were seeing was not just distant space, it was ancient time. Light that had traveled for over 13 billion years had finally reached a mirror floating in space, and that mirror was now reflecting it back to Earth. Every second of observation felt like touching history, and yet neither telescope can ever show the full truth. They only capture fragments, pieces of a much larger story that is still unfolding, because the universe is not finished. It is still writing itself, and we are only reading the first pages. Beyond the reach of planets and moons, where gravity becomes a quiet agreement between distant masses, the James Webb Space Telescope floats in a region of permanent stillness. It is not truly still. Of course, nothing in the universe is. But compared to the chaos of stars and the violent motion of galaxies, its orbit feels like suspension in thought. Webb's golden mirror is not pointed at anything visible to the naked eye. There is no colorful sky, no bright nearby stars dominating its view. Instead, it looks into regions where light itself has been stretched, weakened, and redshifted by the expansion of space. What arrives at Webb's sensors is not the universe as it is now, but the universe as it was billions of years ago. This is the key to everything it does. Every photon it captures is a traveler from a forgotten era. Some left their source before Earth even existed. Some began their journey when the first stars were still forming from raw hydrogen and helium. Some carry the signature of galaxies that no longer exist in any recognizable form. In these early epochs, the universe was smaller, denser, and far more chaotic. Gravity pulled matter together in uneven waves. Massive clouds collapsed into the first generations of stars that burned hotter, lived faster, and died in violent explosions that seeded the cosmos with heavier elements. Without those early stars, there would be no iron, no oxygen, no carbon, no life. And Webb sees their echoes. In deep field observations, it detects faint smudges of light that slowly resolve into primitive galaxies. Not the grand spirals and structured systems seen in Hubble's images, but irregular, unstable formations, cosmic embryos still learning how to exist. Scientists describe these observations with calm technical language, but behind the words, there is something closer to disbelief, because what they are seeing is not just distant space, it is the universe assembling itself. Meanwhile, Hubble continues its long legacy closer to Earth, offering a different perspective. It sees a more mature cosmos, galaxies shaped by billions of years of evolution, star clusters that have settled into predictable patterns, nebulas where the cycle of birth and death is ongoing but familiar. Together, Hubble and Webb create a kind of temporal bridge. One shows structure, the other shows origin. One sees the present of deep space, the other sees its past, but neither can capture the full story, because space is not static. It expands constantly, stretching the distance between galaxies like an invisible force, pulling reality apart. What Webb sees today is already gone in its current form. What Hubble sees is already older than imagination can fully grasp. This creates a strange truth. Every observation is both discovery and archaeology. We are not just looking at space, we are excavating time. And the deeper Webb looks, the closer it gets to a threshold that scientists once thought might remain forever hidden: the moment when the universe transitioned from darkness to light. Before stars, before galaxies, before structure, a time known only through theory, now beginning to reveal itself through faint infrared whispers. In some of its deepest scans, Webb detects patterns that suggest early clustering of matter. Not yet stars, not yet galaxies, but the conditions required for both. Gravity beginning to win against expansion. In localized regions, the first negotiations between chaos and order. It is like watching thought form inside an empty mind. And yet, there is still more beyond this point, because even the first light Webb can see is not truly the beginning. It is already the result of processes that started earlier, in total darkness, where the universe was filled with opaque plasma and radiation so dense that light could not travel freely. That era is called the Cosmic Dark Age, and no telescope can see it directly, but Webb can approach its edge. It can listen to its aftermath. It can reconstruct its shadow. And from that shadow, humanity begins to understand something profound. The universe did not begin with light. It struggled toward it. In the deepest regions of space, where even the most advanced instruments struggle to collect enough light to form a single coherent image, the universe begins to reveal its most violent architecture. James Webb Space Telescope turns its gaze into these regions, not to find answers that are already known, but to witness processes that are still unfolding in their earliest forms. What it sees is not calm creation. It is struggle. It is pressure. It is matter trying to organize itself against the endless expansion of space. In these distant corners of reality, galaxies are not the elegant spiral structures often imagined by the human mind. They are irregular, chaotic formations, clusters of gas and dust collapsing under gravity, fragmenting, merging, and igniting into bursts of star formation. Stars do not appear gently. They are born in compression. Massive clouds of hydrogen collapse inward, heating up until nuclear fusion ignites at their cores. When this happens, a star is born in a violent flash of energy, pushing against the very cloud that created it. It is a battle between gravity pulling inward and radiation pushing outward, and Webb sees these battles happening across entire galaxies. Some regions glow intensely in infrared, signaling star formation so rapid that entire stellar systems are being built within a few million years, a blink in cosmic terms. Other regions appear dark, where previous generations of stars have already lived and died, leaving behind heavy elements scattered into space. These elements become the next generation of matter. Everything that exists, planets, oceans, air, even the structure of human thought, comes from these cycles of destruction and rebirth. Meanwhile, Hubble continues to provide a contrasting perspective. It captures galaxies that are more mature, shaped by billions of years of gravitational interaction. Spiral arms become stable. Star clusters settle into predictable orbits. Cosmic structures gain identity and form. But even in this maturity, nothing is truly stable. Galaxies collide. It is not a sudden crash like objects on Earth, but a slow gravitational dance that takes millions or even billions of years. Two galaxies pass through each other, their stars rarely colliding directly due to vast distances, but their gravitational fields reshaping everything. During these interactions, stars are flung into new orbits. Gas clouds are compressed, triggering new waves of star formation. Black holes at the centers of galaxies awaken, feeding on surrounding matter and releasing enormous jets of energy. These are not isolated events. They are cosmic cycles of transformation. And Webb, with its infrared vision, can see the hidden details of these interactions. It can observe dust clouds collapsing during galactic mergers. It can detect heat signatures of black holes consuming matter at the centers of young galaxies. It can trace the faint glow of structures forming in regions previously thought to be empty. One of the most profound discoveries is that galaxies in the early universe evolved much faster than expected. Structures formed earlier, collapsed earlier, and reached complexity sooner than theoretical models predicted. This forces a reconsideration of how quickly the universe organizes itself. It suggests that the early cosmos was not a slow unfolding, but a rapid emergence of structure, driven by unknown efficiencies in gravity, dark matter, and energy distribution. And still, beneath all of this, there is something even more mysterious. Dark matter, invisible, undetectable directly, yet responsible for holding galaxies together. Without it, galaxies would fly apart due to their rotational speeds. Its presence is inferred through gravitational effects, like an unseen scaffolding supporting the visible universe. Neither Hubble nor Webb can see it, but both depend on it. Every image, every measurement, every galaxy observed is shaped by something that cannot be directly observed. This is one of the deepest paradoxes of modern astronomy. The most important components of the universe are invisible, and yet their effects are everywhere. As Webb continues its mission, it moves closer to understanding not just what galaxies are, but how they become what they are. Each observation adds another fragment to a timeline that stretches back to the first moments of cosmic structure. But even now, there is still a boundary ahead, a point where light itself begins to fail as a guide, a threshold where the universe stops being something we can directly observe and becomes something we must reconstruct from indirect signals. That boundary is the edge of the observable universe, and beyond it lies not emptiness, but unknowable history. There is a point in every observation where data stops being a window and becomes a question. For the James Webb Space Telescope and the Hubble Space Telescope, that point is not a sharp boundary, but a gradual fading, where light grows older, weaker, and more distorted until it barely resembles its origin. At the very limits of the observable universe, Webb gathers the faintest infrared whisper signals, stretched across billions of years, carrying the memory of structures that may no longer exist in any recognizable form. Hubble, with its longer legacy closer to Earth, continues to map regions that feel comparatively familiar, where galaxies have already settled into mature shapes and cosmic history has written itself in stable patterns. Together, they form something unprecedented in human history, a continuous view of cosmic time. But even this continuity is incomplete, because no telescope, no matter how advanced, can ever observe everything. Light has a speed limit, space has an expansion rate, and beyond a certain distance, galaxies are moving away faster than their light can ever reach us. Those regions are forever hidden not because they are small or faint, but because the universe itself is stretching them beyond our reach. This is not a technical limitation. It is a structural one. There are parts of reality that will never be seen, And yet, within what can be seen, the story is already vast beyond comprehension. Every image from Webb reveals galaxies forming earlier than expected, suggesting that the universe may have structured itself faster and more efficiently than current models predict. Every deep field capture becomes a reminder that what we understand is only a thin layer of a much deeper process still unfolding. Hubble's legacy, meanwhile, remains essential. It provides the long-term baseline of cosmic observation. It shows how galaxies evolve over billions of years, how nebulae recycle matter, how star systems stabilize and eventually decay. Without Hubble, the universe would feel like a series of disconnected snapshots. With it, we see continuity, but continuity does not mean completeness. There is still the question of what lies beneath the earliest light Webb can detect. The cosmic dark age remains partially hidden at time, when the universe was filled with neutral gas, before the first stars ignited and illuminated space. No direct image exists from that era, only indirect traces, reconstructed through physics and inference. It is like trying to understand the beginning of a song by listening only to its echo. And yet, humanity continues to push closer, not because it expects final answers, but because each layer removed reveals new structure underneath. The deeper we look, the more the universe resists simplification. It does not reduce itself into a single explanation. Instead, it expands in complexity the more it is observed. Galaxies behave differently depending on their age. Dark matter reveals itself only through influence. Black holes shape entire cosmic regions, while remaining visually invisible. Even time itself becomes relative, depending on gravity and distance. At the center of all this observation lies a quiet truth. We are not outside the universe studying it like an object. We are inside it, trying to interpret itself. The telescopes are not separate from the cosmos. They are extensions of it, machines built from the same element they observe, looking back into their own origin story. Every atom in Hubble and Webb once existed inside stars. Every photon they collect has traveled through cosmic history, shaped by the same physical laws that created the instruments detecting it. This creates a strange loop. The universe, through intelligence that emerged within it, is now observing itself. And still, there is no final image. Only deeper layers, only further questions, only expanding distance. As Webb continues its silent watch at the edge of gravitational balance, and Hubble maintains its long, steady gaze closer to Earth, they together form a bridge across time, a bridge that connects the present moment of human curiosity to the earliest light in existence. But bridges do not end the journey. They only allow it to continue further. And somewhere beyond the reach of both telescopes, beyond even the faintest detectable glow, the universe continues its expansion into unknown regions, carrying with it the unanswered questions of everything that came before. The final truth is not a picture. It is the act of looking, and that act has no end.